So we have one more topic for this lesson, and we will continue on the same topic also next week. But the main topic yet still in this lesson 4 is not so much the visualization of maps, even though we will be plotting maps, but to focus on reclassifying data, which is a very common processing step. If you could have land cover data to reclassify into larger entities, or as we will be now continuing with the Helsinki region travel time matrix. So we will reclassify the travel time values into bigger units so that we can then visualize the data in thematic maps that are easier to interpret. So we have already discussed conditional statements before, and here we will just put them into the context of spatial data, especially, and then pandas data frames in general. So when talking about travel times and the travel time matrix data, we could, for example, ask questions about suitable places to buy a house, if we would, in addition to have some spatial information about average rents or housing prices, we could make a spatial query or some suitability classification for different parts of the region based on travel time. So if travel time is less than 30 minutes and the rent is less than 1,000 euros, that is like my top priority interest area, and then we could add additional conditions in there. Today we don't have the data about housing prices, but we will create some additional conditions based on the travel time information in the travel time matrix. And in practice, we will use a Python package called PySal, and from there, this mapclassify library to create these classification schemes. So we will use these standard classifiers and then create our own custom-made classifiers to classify data based on different rules. And as a case example, we will here then create one custom classifier to find grid squares in Helsinki that have good public transport accessibility to city center, but are a bit further away from the city center, if assuming that prices are a bit lower if you are further away from the city center. And we are using this travel time matrix data that you have already encountered. And this is also one possibility, or most of you will probably build your final assignments around this travel time matrix dataset. So it's good to familiarize ourselves with that already now. And in the first part of this lesson, we have already selected the grid squares that are located in Helsinki, and you should have this GeoJSON file in the data folder. If not, there's also a download link for all the data that we are using in this lesson. Yep. So again, those who have studied GIS before or cartography or plotted thematic maps might be familiar with these kind of common classification schemes. So we can have an equal interval classification. Each class is at an equal interval, or then we can, for example, have quantiles, which then puts equal amount of observations into each class that we have, or then other class breaks based on the distribution of the data. So this PySal mapclassify GitHub page is a good starting point for refreshing your memory about these different options and to check how to actually implement them using Python and this mapclassify module. So there's multiple different options, and most of these are, for example, available in Quantum QGIS if you're visualizing data using a classification scheme. Yep, so I move back to the CSE notebooks environment and open the last notebook. Continuing from here, so the file path is there ready to be read in using pandas. And let's create a variable called ACC that's quick to write, GPD read file FP. Should work just like that. So we have this, each row represents one grid square in the matrix, and then we have these travel distance and travel time attributes for car, public transport, walking from each grid square to the Helsinki railway station. So the to ID is identical in each of these grid squares. One particular thing in this travel time matrix dataset that there are some no data values, for example, in the middle of Nuuksio or in the middle of the lake probably, which are coded with value -1. So we want to exclude those rows from the data. We could turn them into no data values and exclude that like that, but we can also use just a basic selection. And in this tutorial, we will be focusing on, at least in the start, public transport for a change. So PT, rush hour, travel times. So this is the time in minutes from that particular grid square to the Helsinki city center in minutes. So let's take that. You can copy paste it and put it in there. So we want to make a condition. Basically, travel times are positive values, so we can get rid of -1 values by selecting everything that is greater than 0. And if we put the equal or greater than, then we also include the source cell in there. With this selection, we get the data, but we want to store it in memory. This is easy to forget. So we update the values of this variable so that we only have the positive values from that particular column with us, so that it doesn't mess up our maps. So let's start by creating the first map. We import matplotlib to have some additional functionalities available, but mostly we can do things using the geopandas plotting commands. So we want to plot this public transport rush hour travel time column. And then in this geopandas plotting function, there is this scheme parameter referring to classification scheme that already allows us to, on the fly, create these different classifications. Oops. And these names of the classification scheme come from the mapclassify package. So you need to know, I think it's case specific, and you need to know how to refer, for example, to natural breaks classification scheme. The K that we already saw before indicates the number of classes, so how many breaks. And it's a good detail to know that if you have one break, you will have two classes. So if we have 9 breaking points for the distribution, then we will end up with 10 classes. So this is in a way the number of breakpoints for the classifier. Let's see what that gives us. Just with the scheme, the K, and then the column. So here, presumably, darker the shade, the closer to the railway station, which is located in here, the brighter the shade, the more further. Makes sense. If you want, you can change the color map. No, it's a bit unfair, but I will copy paste it from the lesson materials. So there are these standard color map names. So this is, for example, red, yellow, blue, maybe, let's see. Yes, so from red through yellow to blue. So in a way, hot areas, then middle areas, and cold areas. It's quite a nice color scheme for visualizing these travel time values that indeed go from like very close to in the middle and then very far. So you can read more about choosing these different color schemes from this Matplotlib documentation, or this is one of the pages. So for example, in here, we have this now, this, what did we use? The red, yellow, blue. I don't know if it's listed in here. It's one of these diverging color schemes. So we now use this red, yellow, blue, but all of these other pre-named color schemes you can then use for visualizing your data. And of course, it depends on the phenomenon you're visualizing. Is it something that increases constantly, or do you want this kind of bipolar or this diverging thing that shows the hot and cold areas and so on? But this one is quite nice for travel times. And then maybe one more useful thing is the legend. Oops. Legend. I'm just too tired to spot the typos. So, well, layout-wise, this is not so nice yet, but we are more interested in the classification scheme. So here you can then see the map legend. We will learn later how to position it more nicely in the figure frame. So you can see the actual values and also interpret what were the breakpoints now in this natural breaks classification scheme. All right. There's this use type layout. I don't know if it actually changes anything. But sometimes when plotting maps, yeah, I don't know if it really changed much, but sometimes it helps to reposition different figure elements so that they are reduces the amount of white space in the figure. Okay, so we have the column we're interested in: classification scheme, natural breaks, number of breaks, color map, and legend. So let's do so if you're following me. So if you triple click, you can select the whole row and then Control-C, copy paste the same syntax down here, and we can start modifying it to save some time. So let's just change the column. So walking distance, the hour, we can skip that. Just using the same amount of breaks in the same classification scheme, same color scheme, but now walking distance in meters. So then you can see that we get a bit different pattern on the map if we change the column. And then we might want to think that is this now the color scheme we want to use for walking distance. Yep. But also to familiarize ourselves further with the data. So these distance values, they're more linear, while then this public transport travel times, you can kind of see the stations in there as hotspots and so on. But let's continue discussing about these classifiers and data classification. So in here, what we did is that on the fly, when plotting the data, behind the scenes, GeoPandas and mapclassify calculate these breakpoints, assigns the different polygons, so these grid squares we have in the data, to the classes, and then visualizes them based on this classification. But sometimes we might want to have the actual classification in a column to have the class labels stored in the file for further analysis or other purposes. So we can import mapclassify separately. You need to have it installed using Conda, and then create these classification schemes as objects. So let's see what this natural breaks actually is about. If we have mapclassify natural breaks, and then it asks for a vector of data. So we pass a pandas series that is one of these columns. We can take the public transport rush hour travel times. So let's do the same classification as we did. So these natural breaks, basically the software then looks at these, if there are some gaps in the histogram of the data, or some points where the data kind of naturally breaks into the amount of classes that we have asked for. And there might be, as you can see in the first class, so those that are very close, there's lower number of data, and then in further travel time zones, most of the data is located in there. And then again, in the furthermost one, there's again less amount of data. So in this way, if you want to have, for example, the class values for further processing, you can then print out the information through mapclassify. Let's take another example of a classification scheme, which is quantiles. Often a good classification scheme for visualizing, for example, then different variables. You get the kind of, you can, for example, get top 25%, bottom 25% of data, and everything in the middle. And I think by default, quantiles, it will produce us 5 classes. So we pass the same array of data, or the pandas series, like this. Oops. And I think this needs to be, so this is kind of, it's capital Q because it's in a way a class constructor, not a function. But yes, so here then you can see it tries to balance the number of observations in each class, but then also avoiding to put, it's not completely equal, but pretty much close to 700 and something observations per class. So then those values that are close to the class threshold might go to one or the other. And indeed, if you need for some purpose, let's copy paste this one, for example, from here. I store it into a variable. Separate cell. And then if you call bins, so this is now this kind of mapclassify object, and I call bins. So then I get these breakpoint values that I had that are then the basis of the classification scheme. So these pieces of code you rarely need to actually use, but it's good to know that you are able to, if you're making these maps using GeoPandas, it is possible then to fetch these breakpoint values and the number of observations per class using the mapclassify module in a bit more advanced way. Okay, and then we can also apply these classifiers on our data to get kind of label each row into the associated class. So let's, I go again back up, copy that natural breaks classifier. Actually in here, what I will do is I modify the code a bit. So here, if we want to apply these classifiers on the data and get the classification scheme in a new column, for example, or as an array or pandas series, we will make a classifier. And then in there, we can pass the number of breakpoints as a parameter. So in a way, this is then, you can think of this classifier now as a function that we can then apply on our data frame. So then if we have the data, and here I want to pass it as a pandas or a geodata frame or a pandas data frame, not an individual column. So I have these double brackets in there. Let's again take this PTR TT, so the rush hour travel times, and then I apply the classifier. I think it might, let's try if it works same way if I just pass the column. But in this way, I kind of get an indexed classification for my column. I'll just try what happens if I do like this. Yep, it doesn't work. So applying stuff on one column like that. This doesn't work. Let's do it as instructed. So you could have, of course, multiple columns and apply the same classifier on all of them. Now I pass a pandas data frame, apply the classifier in there. So now for each row in this Helsinki travel time grid, I get kind of this class number for each row. And this output is, if I now finally remember to store my results, for example, we can call it classification, print it out. So, oops. So here we can't see all of the class numbers, but this output for each row of data, we have numbers from 1 to 9. Let's verify that. Actually, I want to be sure how many values we have. So classification, then we have this PTR, TT, and then value counts, not to take it from the top of my head. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 distinct values. And then this, so these are the kind of class labels. And then this is the number of rows in each class. So the same information we got earlier, but now we have stored the information of the class in a pandas data frame. Not always needed, but sometimes a useful thing to do. So furthermore, we want to now that we learned how to do this, let's store the output in our original data frame. So, well, there's a suggestion of a bit cryptic column name, but let's use it. So natural breaks, public transport, rush hour travel times would equal to what we just did. So applying the function on the public transport rush hour travel times passed as a pandas data frame, and then applying the classifier. So now might be difficult to see all of the columns if I do like this. Take both of these. You don't need to do this if it goes too quickly. I'll just demonstrate and show once you have managed to update the column with the classified values. So I check the first rows of these ones. So the public transport rush hour travel times are the original travel times in minutes. And then this natural breaks contains the actual class value of each grid square. All right. So yeah, based on the silence, I hope everybody is still following. So now we can create the same plot that we were able to plot using this simple one-liner, but now we actually know what is happening with the classification. What are the values? How many data points or grid squares do we have per class? And then we can plot the data again. So ACC plot, then we have this, I'll just copy paste it from here. We should optimize the names of these columns to make them faster to write. Side note, if you're using shape files, that's why you want to have very short column names, because shapefile only allows, I think this is even too long to be stored into a shapefile. So shapefile cuts at 8 characters, I think. That's why the travel time matrix column headers are so short. We can plot it, and we get the same map as we had before. We could then add the color map, add the legend, and so on and so forth. One other curiosity that we will dive into next week, if you are not using the classification scheme, you get this kind of default matplotlib legend object. If you use the scheme and the classification scheme through mapclassify when plotting, then you get this classified legend in your figure. So this might then cause some trouble next week when we are plotting the maps. But let's then share our best tricks and tips how to adjust the legends also programmatically. At the end, you can then save it as a SVG file and do the rest of the layouting in some graphics software. But of course, we want to, as far as possible, automate also the plotting of maps. Great. So we have now learned how to plot using GeoPandas defaults, using a classification scheme. Then we have learned how to actually understand a bit more about the classification scheme, now using this natural breaks classifier, storing the actual values in a column, and then plotting the classified values, having a bit more control of what is happening. One final thing when thinking about data classifications in terms of plotting or otherwise is to look at the histogram. So let's plot a histogram of the data. At this point, this function is, well, at least was available in ArcMap. I think in QGIS, you can also visualize a histogram, but it's a good way of understanding what is the most suitable classification scheme for your data. There are no absolute correct answers to selecting the best possible classification scheme. We can have a discussion about it, but then there are, like, if you have a skewed distribution or a normal distribution, then some classification schemes are better than the others. So let's take our rush hour public transport travel times to railway station and plot hist. Not more difficult than that. We get a nice bulky Lego histogram. If you want to kind of make it more detailed, there's this bins parameter that then adds a bit of detail. So on the x-axis, we have the travel times in minutes, so ranging from 0 to over 2 hours. So 2 hours is here. Most of the data is here within like 1 hour travel time in Helsinki to the railway station. So that's already useful also for describing the data, and the frequency refers to the number of grid squares. And then if we want to kind of mimic this, well, I have this nostalgia towards the visualization tools in ArcGIS, the tool that I was learning these things back in the day. So I would want to, if I'm creating a classification scheme, see actually the breakpoints on top of my histogram as, for example, straight lines. That's possible to do. So, and for that, we need to actually access the values from the classifier itself. So I'll just type it all in. So I recreate the classification for my column of data, TT, and then these 9 classes. For example, you can then test others. Then I copy paste the code from there to plot the histogram. Check that I don't have any syntax errors. And now I would want to have the breakpoints from this natural breaks classifier plotted on top of the histogram. So I fully understand what happens when I classify my values using these natural breaks. Where are the natural breaks? What does it mean? So we come back to matplotlib. There is, I think we did, well, maybe not exactly something like this, but there is a function axvline. You can Google further details. And if we would want, let's just plot. So I think this refers to vertical line. So if we plot a line at x value, vertical line at x value 40, let's change the color into K, which is default for black. So using this, I can just manually add a vertical line on my plot. But then I would want to add a line for each breakpoint in my classifier. Possible, but for that I need a for loop. So for value in classifier bins that we learned just a few minutes ago, I want to plot a vertical line at value. Let's see what we get. So this PLT plots to the active figure object that we create in here. And this works now that we have everything in the same code block. So that looks quite nice. We can make it even nicer if we change the line style. And then maybe the lines are a bit thick, so I have tested before that line with 1 might be nice. So this already like feels familiar to me from the early freshman days of sitting in the GIS labs and thinking about map classifications. So here for this public transport rush hour travel times, using mapclassify natural breaks. The natural breaks are, first one is at close to 20, then there's more breaks where there is a lot of data, and then when in longer travel times there's less data, so then the natural breaks are further away from each other. So this is a useful thing, for example, for your final project, if you really do proper data exploration and justify your choices for example, thematic map classifications, you can plot a histogram with these vertical lines. Yeah, it's getting late, so I will cut some corners in here, I think, but yeah, I'll do so just to wrap it up. For quantiles, I copied the previous syntax. I just changed the classifier. Let's take the default number of classes, repeat everything else as before. So these are then the quantile breakpoints, which try to balance or kind of have an equal amount of observations per class in here. Okay, so there's a lot, would have been a nice check your understanding for you to experiment then with different classifiers, but I leave that for you as homework. So feel free to copy this piece of code, read the mapclassify documentation, and try out different parts. I think it is useful if I still explain this last part. So if you're super tired and don't have any energy to follow, you can check this from the lesson video, but I will take maybe, well, max 15 minutes more to finish up the lesson. And then otherwise, exercise 4 is available in the web pages, so you can then start working on that. There, the contents are mainly about this intersection operation and working with the travel time matrix data. But I will still explain this last section of this notebook to get it recorded in the lesson video. So far we have been using these existing classifiers from mapclassify, which often are enough. But then if we really want to reclassify data based on our own criteria, coming back to this example at the top of the notebook about finding regions in Helsinki that are close to the city center with public transportation, but a bit further away, assuming that the housing prices are not so high. So for that, we can create our own classifier. The code is here. I'll explain it briefly. So this custom classifier will code the data into 1 or 0, depending on if a criteria is met or not. As input, we will always have 1 row of the data. So we will apply this classifier on our data frame. We have 2 source columns, so we will have conditions based on 2 different columns based on some threshold values. So threshold 1 is associated with source column 1, and threshold 2 is associated with source column 2. And then the classification output 0 or 1 will be stored in output column that we can then specify when applying this function. So when applying functions on pandas data frames, it's often easy to copy the whole definition or the first line of the definition like this. And in here, then indeed, it takes the row for the first column has to be less than something. And then for the second column, it has to be greater than something else. If these conditions are met, then the output column value will be 1. In all other cases, for that row, output column value will be 0. So you need to run this cell to have the classifier in memory. And we will classify the travel time data so based on 2 criteria that we will get cells where travel time is lower than 20 minutes, so close to the city center in terms of travel time, but further than 4 kilometers away in terms of travel distance to exclude the most expensive areas in the city center. And we will store the output in the column suitable area in our accessibility data frame. So then all is left is to apply the function. And when we apply it, we want to update the values eventually, and then accessibility.apply. And then in the apply, we give the name of the function as the first parameter. The row parameter we don't need to pass, because when we apply the function by default, the first parameter that gets passed in here is 1 row of the data. Our source column, so first condition was, I'll put this like this so it's easier to read. So source column, we want travel times to be lower or equal to 20 kilometers, 20 minutes. So public transport, rush hour travel times. Then second condition will be based on distances. So public transport, walking distances. That makes more sense. First threshold related to source column 1 is 20 minutes in the unit of the values in the column. Second threshold is 4 kilometers, 4,000 meters. And output column is suitable area. We need to add this axis 1 in order to apply the function on each row of this data frame. And then let's add to the same code cell a head function, and I for sure have some syntax problems, comma. So apply function name, function parameters, and then axis. There we go. It went quite nicely, at least no syntax errors. I will move here. Just to check our column. So there's many cells that have 0, which are non-suitable. So suitable or non-suitable, but if we check value counts, so we can check that there are actually 9 grid squares which are suitable. So not too far, but not too close based on our criteria, and then all the rest are non-suitable. So now we could start adjusting our thresholds. If we want to change the results, you could then adjust the thresholds in here if you want to allow 30 minutes public transport time and maybe but 5 kilometers away or so on. So then these parameters will be applied on the data, and then the column values would be updated. But let's be happy with these 9 grid squares. Plot column. Well, if I now plot the data and classify based on this suitable area column. So it's a binary column. I will get a 0 and 1 classification. let's see what we get. Display our typo following me. So it's a bit tiny, but you can see that from the kind of northeast side, is it then in Herttoniemi, old Herttoniemi, and somewhere along the eastern metro, there are some grid squares that are plotted in yellow in this case, so the default color scheme. And then if adjusting the thresholds, you could maybe find larger areas that are suitable for then searching, for example, a house to rent. So you probably won't need to make such a complicated classifier, but I hope this, now that we have seen this custom functions being applied on pandas data frames many times, I hope you grasp the idea a bit better at this point. So it didn't take too much time to finish this lesson. We have covered everything that was planned for today.